Ready? So the result of first term is already published. There is one saying, morning shows the day. If you have deserved better grades, then definitely in SC also you will deserve better grades. But if you have got NG, then it's very challenging for you. And if you start deserving less than 3.6, it is same for you also. Because you are the product of Anupam. And you are smart students. Many students, they have become smart students. In 2017, 9, 80, 81, right? Yes or no? Some they might have become smart students for 2 years. Some 1 year. This time also we have become smart students. Who was first? And Baisakh? Pujana. Jest? Bian. Asad? Jai. Okay, now sound, which tone, we don't know. So, smart students will not be repeated. Once they have become smart, they should not go down. Or you want to be smart? E-smart. Electronic smart. Many are electronic smart. For study, GPA very less. For electronic gadgets, very high. Okay, today there is presentation from Shrijal Karki. So let's welcome him on the stage for better presentation.
Namaskar everyone. It's me Shrijal from Britain. So this is my topic, chapter web. So my topic for today is total internal reflection of waves. So two diagram is given here, a dry coin and a coin with water under beaker. So here are some process or rules. So first point is place a beaker with water covering its upper surface with a cardboard over a count as shown in the figure A. So this one is the figure A. And the second point is observe the coin from the sides of the beaker. So you can see the coin from the sides of the beaker, but the coin is not seen. So if not, why? The third point is now drop the water over the coin and place the beaker again over it. What happens now? Don't get surprised. It is not a magic, but it is due to property of light called total internal reflection. So figure A is explained here. To understand the process, study the given diagram which is given on the next page. So again a diagram or a figure is given which is total internal reflection. So total internal reflection of waves. In the given diagram, there are two optical mediums as a denser medium and air as a rarer medium. So this is the figure. So this is the figure. Suppose a ray AO. So the ray is AO. It's passing from glass to air, which was given on the previous figure. It bends away from the normal MN, and MN means this one, which is straight and vertical, as OA power 1. Here angle AON, which is AONN, is the angle of incident. This one is the angle of incident, and angle A power 1 OM is angle of refraction. So AONM, this one is the angle of refraction. When the angle of incidence is increased continuously, a condition may come when the angle of refraction, angle B power 1 ON in the rarer medium is 90 degree. B power N ON means B power N, B and ONN. So this is the 90 degree. Now the angle of incidence in the denser medium, angle BON, which is BONN, is called critical angle. So BON, this is called a critical angle as shown written here. So next topic. If the angle of incidence is increased beyond the critical, angle, all the rays reflect within the denser medium. This process is known as total internal reflection. Therefore, when a ray of light passes from a denser medium to a rarer medium with the angle of incident greater than the critical angle, the ray is reflected back into the same medium. So this phenomenon is called total internal reflection. So that was about total internal reflection. So next topic is about Mires and looming. So this is the figure of Mires given here, which is in which a man is observing a tree, and which is this is a virtual image. Is observing two images, one is virtual image and one is normal image. So reflection bends light rays towards the cooler air. So from he looks here, this is the cooler and that was the warm air. And the next figure is about looming. So previous figure about Mires was a man observing Mires in desert, and this one is about looming in ocean. So both are same thing, but that was in the desert or land surface, and this is in the ocean surface. So same thing is happening here. So next one is Mires and looming are products of total internal reflection. Mires is an optical illusion that occurs on a black tarred road and in the desert, creating a false layer of water at a distance due to the sun's heat. When the surface of the earth is heated, it warms the lower layer of the air just above the ground, which is a rarer medium relative to a colder air found above it. In this condition, when the rays of light from any object in that region enter from a denser to rarer medium, they refract. It means the rays of light from any object that enter from a denser or to rarer medium, they refract. So looming is on the next page. Looming is another phenomenon that occurs in the evening over the ocean. During the evening, a cold layer of air is found closer to the ocean surface with a layer of hot air over it. In this scenario, rays coming from distant ships undergo that internal reflection of downward, causing the formation of an image of the ship above the ocean. So this was all about Mires and looming. So thank you everyone.
Okay, thank you very much, Shrijal. So he has made the slide with great interest, and thank you also is given. So mainly we have to remember one, critical angle. What to learn? Critical angle. Next one is total internal reflection. Hey, so one condition is there: when a ray of light goes from denser medium to rarer medium, here glass is denser medium, air is rarer medium. So when a ray of light goes from denser to rarer, it bends away from the normal. I mean, look at here. This is angle of incidence. What is this? And this is angle of refraction. This is R. Angle I is less than angle R here, right? Again, when we increase the angle of incidence, in one condition, the angle of refraction will be how much degree? 90 degree. The angle of incidence which makes angle of refraction 90 degree is called, what do you call it? Critical angle. This is the critical angle when angle of refraction is how much? 90 degree. If angle of refraction is 89 degree, then that is not critical angle. So angle of incidence is critical angle if the angle of refraction is how much? 90 degree. But if we increase the value of angle of incidence more than critical angle, if I is greater than C, at that time the ray of light reflects back in the same medium. See, this is incident ray. What is this? Reflected. What is spelling? REFLECTED. What is that ray called? Reflected ray. So angle of incidence, angle of refraction. Here will be I equals to R. Angle I equals to angle R. Right? So this process is called total internal reflection. How to define total internal reflection? When the angle of incidence is greater than critical angle, angle of incidence is greater than critical angle, the ray of light reflects, not reflects, reflects back in the same medium. This phenomenon is called total internal reflection. We discussed last time two conditions for total internal reflection. How many conditions are there? What is the first condition? What is the first condition for total internal reflection? The ray of light must pass from denser medium to rarer medium. Ray of light must pass from denser to rarer medium. Okay, just a minute, I'll show you. Two conditions must be given here or not given. Here. The incident ray must pass from a denser medium to rarer medium. Next one, angle of incidence in the denser medium should be greater than critical angle, right? And here we have to remember this total internal reflection can be applied in different phenomena. What is one? Mirage. What is this? Mirage. Mirage and looming, you can see here. Mirage occurs on desert, looming occurs in ocean. It means it occurs on land, it occurs on water. So what is the difference? In mirage, one pool-like structure, pool. Artificial pool is developed in this region and its image can be seen over here. Like the people who are walking in that desert during daytime, sometimes they may see, one small pool is developed over there, and they can observe, now our thirst can be fulfilled. Because it's very hot there, no? They become very excited, go a bit far away, near to that body, but there is nothing. That's why it is optical illusion, Jadoo type structure. It seems as if there is, but when you reach there, there is nothing. That is called virtual. So, what is the difference between looming and mirage? In mirage, the image is seen downward, but in looming, the mirage is seen, the image is seen upward. See, the person can see one pool-like structure here, and image of it can be seen here. But in this case, when he is walking in the sky, what can he see? Another ship is there. The ship is really in that water, but in looming it can be seen up. Why? Because there are two layers of air. One is cold air, another is hot air. Cold air, hot air. Here also, cold air, hot air. Now tell me, in between cold air and hot air, which one is denser, which one is rarer?
Hot air.
Between cold air and hot air, which one is denser, which one is rarer? Hot air is rarer because its density is less, its density is more denser and rarer. So here the person is walking, right? Suppose his eyes, they are in cold air, down what is there? Hot air. When light flows or passes from denser to rarer, it bends away from the normal or not? So that what can be noticed over here? One image can be noticed. Okay, one image can be noticed. Here also, down what is here? Cold air. Here is hot air. So here we have to keep in mind, mirage takes place during daytime, mirage during day, and looming takes place during night. Because in case of water, this lower surface is cold, upper surface is warm during night, right? And here, daytime, here is hot, here is cold to air. He has to sit down, he sits upward, right? These are the two things to remember. I think he explained these things. Now, whose turn to explain? Which duty is there? Minimum 4-5 slides are there, you will send one. Sir, my question. Yes, they were talking about smartness of yours also, boy. That means who is fond of doing less work, that is a smart student? Very bad habit, no? Okay. Now in this time, what you are going to do, I will tell you to draw some diagrams, you do it, okay? So diagrams time. Diagrams time, okay, open your book.